Okay, today we're going to be looking at geometric series. There's three parts to it. The first one is just looking at geometric series terms, and similar to the arithmetic ones which have a common difference, a geometric series terms that have a common ratio. So our notation tends to be A for the first term as always, and then we multiply by whatever the ratio is R. So we have AR for the second term, AR squared for the third term, and so on. Notice that the power of R is always 1 less than the position in the sequence. So the nth term is AR to the n minus 1. And our general term, I like to use this one rather than just the nth. The nth to me is the last one only, is UK equals AR to the k minus 1. And as we'll see with the examples, you can do some fudging if you're given particular terms, but if you're given the value of a particular term and the sum of, and we'll come to that later, it's important to use a formalised version to actually set up your working, or else you're going to be in trouble basically. So let's have a look at the first couple of examples then. These are our first few terms of our series. It goes onwards from there. 48, 72, 108, 162. It's probably not a bad idea to state A equals 48 and R equals 72 over 48, 24, 3 over 2 or 1.5. Okay, so our nth term then is just A 48 R 3 over 2 to the n minus 1, and that's all we need to do for our nth term for our last term. Our 8th term then is 48 times 3 over 2, n minus 1 is power 7, so press some buttons. 48 times 1.5 to the power 7 equals, oh gosh, apparently 820.125. That's our 8th term. Example 1b, 6 minus 12, 24 minus 48. The fact that it alternates tells me that the ratio is negative. So A equals 6 as before. R equals minus 12 over 6 minus 2. So our nth term then is 6 times minus 2 to the n minus 1. And our 8th term is 6 times minus 2 to the power 7. So 6 times bracket minus 2 to the power 7 equals minus 7, 6, 8. Nice and straightforward. Okay, if we're after a particular one, then we're using this general version here. If I'm going to do the 10th term, that'll be AR to the 9 and so on like that. So let's have a look at how your typical question might look. We're given particular values. We're told the 7th term is 384, the 11th term is 6144, and we're asked to find A and R. Just like the arithmetic, it's simultaneous equations. And in this case, just like the arithmetic, when we're given terms, we can fudge it. We can use common sense and go and say, to go from the 7th to the 11th, I've gone to the 8th, 9th, 10th, and the 11th. And that's R to the power 4. So I can say that when I do one divided by the other, arithmetic we're subtracting, this one we're dividing, I'm going to end up with R to the power 4. Well, let's show it formally then. What I can say is that if I divide them, my 6144 over 384, U11 is AR to the 10, and that's the 7th term is AR to the 6. The A's cancel out, that's the whole idea, we're eliminating A, and that's how we get our R to the 4. So we can sort of, that's my fudge, that's the formalised. I prefer this because when we're told the 7th term is this, and the sum of the first 11 terms is something else, and that'll come later on, you can't really do this fudging in that situation there. So R to the 4 then is this, so R is the 4th root of whatever 6144 over 384 is. Press some buttons and have a look. So 6144 divided by 384 equals 16, and the 4th root of 16 is 2. It could be, or minus 2. We might have to look whether we're looking at, I might have to just check, and it says given that every term in the sequence is positive, so in this case there I can eliminate that one since we know that R has to be greater than 0 to get positive things there. So I know what R is, I can stick it into one of these, not 364, 384, so it's A times 2 to the power 6, so A is 384 over 2 to the 6, and that's whatever that is. So 384 divided by 2 to the power 6 equals 6. So be aware when we've got even roots to get r, we've got a plus or minus. So read the question carefully. The question said had to be positive, so I can ignore the minus 2 solution. So r has to be 2 and a equals 6 in this case here. And lastly, we've got, I think we're going to involve a bit of logs with this one. We're told the sequence goes 3072, 2304, and gets smaller and smaller and smaller, and we're after the position, the first term that goes below 12. So we're going to solve it equal to 12, get a value for k, the position, and from that we need to round up, no matter what the value is, because we want the first one that goes beyond, so it's below 12 in this case here. So let's see what we've got then. A is 3072, R is whatever 2304 divided by 3072 is, and that's a little bit beyond my basic cancelling down, so let's have a look. 3072, 3/4. Who'd have thought it? So what I'm trying to solve is the kth term, so it's AR to the power k minus 1 is equal to 12, is what I'm trying to solve here. So it's 3072 times 3/4 to the k minus 1 equals 12, or 3/4 to the k minus 1 is 12 over 3072. Press buttons and get that. And then, because I'm after something in the power, it's a logs question. K minus 1 log 3/4 will be log of whatever that answer is there. So k minus 1 will equal log of this fraction here, so 12 divided by 3072 is this, and I'll choose ln, it doesn't really matter as long as I'm consistent. So ln of answer divided by ln 0.75, that's 19.27, so k will equal 20.27 like that, so k equals the 21st term is the first one that goes below 12. Okay, so read the questions carefully, all the little bits, be aware that when we need to find the power, we're looking at logs, and that's all there is to that.